Hmm. Welcome to the Data Future channel. This is Shekhar, and in this particular session, we are going to develop a machine learning model which can predict or detect whether the credit card transaction is fraudulent or it's a legitimate transaction. So here we are going to develop a machine learning model which can predict the type of transaction. So it's a classification problem. Okay, so let's get started here by using a Jupyter notebook. So first step is we have to import the required libraries. Here I am importing the NumPy, Pandas, Matplotlib, and Seaborn. The NumPy and Pandas are the data manipulation libraries, and Matplotlib and Seaborn are the data visualization libraries. Okay. Next one is the step data pre-processing step where we have to load the data first. So to import the data, what my data is there, that is the credit card.csv. I am having a CSV file and I am reading it by using a pd.read underscore CSV, and I'll display the first 5 rows. Okay, so I'm storing the data in here in this particular data frame, that is the credit card. Now you can see that here we have displayed only 5 rows and 31 columns. So you can see these columns, there is no any specific column names, but there is a time and V1 to V28, then amount and the class. So class is if it is fraudulent, then it will show 1, uh, and if it is a legitimate transaction, then it will show 0. Okay. Yes, then we'll do some exploratory data analysis. So first the number of rows and columns, and for that what you have to do, so you have to just uh, do the credit card dot shape. So here you will get the number of rows are 284,807 and 31 columns. Okay. So you can display first 5 rows, you can display last 5 rows. So from that you can understand that the all the data is numerical data. Okay, and mostly the time is the discrete type of data, and rest of all the continuous data. There is a floating points you can see everywhere. So the class is again are in district values 1 and 0 only. Okay. So we can do the information about the data. So this is the all the informations which will give you the non-null values of each and every column. So I think there is a no any null values present in the data set because there is a no mismatch in these values, right? So this is all the information, and you can see all the values are float, and finally it's integer, that class type. Okay, we can check how many null values. So there is no null values are present in the data. So data is very clean, okay, and quality data we can say. So here you can check whether there is a duplicated values are there or not. Yes, there are 1081 values are duplicated. So before checking that, you can check like this whether these values are duplicated values are present in the data or not. So it is showing it's a true, means there are duplicate values and their duplicate values are 1081. Now you can see the shape of this. So we have to remove the duplicate values. So what we'll do, so dot duplicates here, and we are creating the data. Okay, so credit card data. So credit credit card new data, I'll say. Okay, new data, and I'll show here, save it here, and what I can see here, dot shape is there. So we can remove it, and you can see that there is a difference. So we have removed 1018. So already we know that 1081, these records are duplicate one. So next one we are going to use this. No need to display the data, but you can display the columns. These are the list of the columns which are there in the data set. Again, I am checking whether there is any duplicate values. Here you can see it should show false. Yes, false means there is no duplicate values, right? So we'll do the class value count. So value count, where you can see the zero means there is a legitimate transactions are 283,253 and the fraudulent transactions 473. So when you plot this on the graph, so you will see there is a huge difference among these two values. Okay. So from this we can conclude that the data is very imbalanced data. Okay, this data is very imbalanced. So you can see that 283253. Okay, so our total data set is what? How much it is? So that is this one. Okay, so you can check the percentage of these values here. Okay, so this will give you this 99.83% data is legitimate data, and here I'm going to use this 473, and when you run this, that is the 0.0016 means not a 1% data is legitimate one. Okay, so very imbalanced data is here. So you can see that when you do the data describe means it will show uh, these things. It will show the statistics of the data, numerical columns. So our new data set is credit card new. So when I do here, so you can see there is a basic statistics. You can see there is a 5 point summary, 5 number summary, and these count, means, standard deviation, 25th percentile, 50th percentile, 75th percentile, maximum value for all the columns. Okay, you can see for all columns. This column is doesn't make any sense because it is having the value 0 and 1. Okay, that's fine. So this is all about the statistics we have seen here. So let me just the statistics and of the numerical columns, we can say. Okay, now we have to convert the data in dependent and independent variables. Okay, so here what we can say, this y is capital Y is dependent variable, and x is independent variables, variables. Okay, variables. Okay, so this is the data. So we have to separate out this data, the dependent and independent. So x, I'm dropping it from the new data, that column itself, that class column. So class column is the our target, that is the y value, right? This is the y. So this is our target column. So here we are separating the data x and y. You can see that. Okay, but the main problem with is this here in this particular data set is the data is highly imbalanced. So in that case, our prediction may bend towards the majority class. So majority class is the legitimate one. So the machine learning will learn these the patterns from the legitimate transactions only, not from fraudulent transactions. So for that we have to make this data balanced one by using some techniques. Um, there are some resampling techniques are used here. So, but you can see that random undersampling, random oversampling. So here, undersampling means we are reducing the samples of majority class. Oversampling means we are increasing the samples of minority class. Okay, then there are few techniques are also there. Okay, but we are going to use the synthetic minority oversampling technique, not the undersampling one. So here you can see that oversampling technique is there, and here this is under sampling technique. Okay, synthetic minority under sampling technique. So this one. So but here we are going to use this synthetic minority oversampling technique, which is popular one, which works by randomly picking the data point from the majority minority class and compute the k nearest neighbor for this point. The synthetic points are added between the chosen data and its neighbors, right? So the four steps are carried out in this particular scenario to create the synthetic samples. It will choose the minority class samples as the input vector, find the k nearest values. Okay, then choose one of the nearest and place the synthetic points anywhere on the line joining the point under the consideration and the chosen neighbors. Repeat the step until the data is balanced. So these steps are carried out. So you can see that our data is here, this one, and this is the x and this is y. So x is independent, y is dependent one. Okay. So to do that, we have to install the IMB learn. So IMB learn. So from that we can import the oversampling and import the SMOT. Okay, uh, synthetic minority oversampling technique. Okay. So when I run this, because already I have installed, you can install it by pip install IMB learn here. Now I'm creating the object of this mode. Okay, so and I'll use that fit with the resample x and y, right? So x mode and y mode, it will create the two samples right here. Now you can see that uh, it has created a total of 566506, means earlier it was 28. You can see that 28, this plus this, you can see 567452. Okay, so uh, here it has added this. So why it is showing this um, this number? Because let me check it once again. Credit card new. Okay, we have run this. Okay, the problem. Okay, here is let me check. Fraud is new one. Sorry. Uh, let me do it once again here, because this is the fraudulent transaction, because we have changed these data now. But I think it should show the same samples, right? Why it is showing like this? Don't know. Here, when you do that resampling, then it is it a matching? Okay, xf. So xf is x underscore smooth. It is showing a 566506. So why this difference is showing? Let me check once. 567452 minus 566506. Okay, 946 records are difference here. So it has created these samples. Okay, that's fine. Then uh, yes, so y value count, you can see now these are matching, right? So 283253 and 283253. So it has made the correct one. Okay, so no need to do this analysis here. So in the y smooth, you can see this is now balanced, right? So here you can see earlier the original. Here I am using a counter from the collection, that module, and counter of y and y smooth. So here you can see the original data set. These are the numbers, and now it has converted this 0 to this value and 1 to this value. So now data is balanced. So you can do the data visualization here itself. Okay. So before doing the data visualization, Okay, so instead of splitting the data right now, so we will visualize the data first. Okay, so we'll put this step later on before building the machine learning model. So before machine learning model, we have to put this step here, and what we can say. So we can train and split the data into training and testing. Okay, so I'll put it here, then mark down and run this cell. Okay, now here. So before that, we have to visualize the data. So how to visualize this? Already we know that this is our data is credit card new data. Here it is. Credit card new data is there, and you just put it here for, and this data is legitimate. Okay, so now you can check here the amount. Okay, and for the legitimate also you can check the amount. Okay, for fraudulent data you can see this is the distribution of amount, and for the legitimate data you can see this is what we can say it's a distribution. Okay, yes. So we can plot the box plot here also by using this plot kind is equal to box. Okay. So here you can see there is a lot of outliers are present in the fraudulent data, and legitimate one you can see there is a less, but again yes there are outliers, but less number of outliers are here. Okay, so distribution is completely different for the fraudulent and legitimate transaction. Okay, now we can find the correlated matrix for credit card, the before imbalance and after balanced one. So for that, we will find the correlation matrix. So what is the correlation among this? So what you have to do, dot core function is there. So you can see the correlation among this before the imbalance, before the balancing. Okay, for imbalanced data, there is no any specific correlation among these variables. Okay, and this is um, you can plot the heat map also by using a SNS dot heat map. So you'll get the nice heat map of the variables which are for imbalanced data. But with the balanced data, you can see this is the correlation matrix, and here is we can see the heat map, the correlated matrix for the balanced. So you can see there is a correlation among these values, and I think this is fine, right? So yes, that is fine. Okay. Then what is this? Okay, this is the count plot for before balancing, means for the imbalanced data, and this is for balanced data. So you can see for the balanced data now these two values are same. Two classes are having the same count now. Okay, fine. So next part is we have to split the data into training and testing. So here I'm importing a train test split from model selection. So xtrain, xtest, ytrain, ytest. So train test split, xmod, ymod, test size is 20, and random state is 42. Okay, fine. So our data is splitted. Now next stage is we have to build the model. So here we are building a logistic regression basically because there are two categories. So I'm importing a logistic regression from the linear model and creating an object of it, and I'm putting a random state is equal to 42, and I'm fitting training the model by providing xtrain and ytrain. So I'll run this cell. So my model is ready for the predictions. Okay. Yes. So it will take certain time because this data is huge one. Okay. So still it is running. So the model training is going on in this particular phase, and yes, now model is ready. Now we can use this logistic regression model, logistic underscore model dot predict x states, and we are putting this into a y predictions. Okay, now we are having the predictions. Now we have to check the performance of the model based on the accuracy, precision, recall, F1 score, ROC, AUC curve, confusion matrix. Okay, so uh, so you can check here these matrix, evaluation matrix. So first I will create a confusion matrix and the classification report. So I have to import these matrix, evaluation matrix from the sklearn dot matrix, and then I'm creating a logistic classification report for the logistic regression. So for the classification report, we have to provide the y test and y prediction, means y true and y prediction. Okay, and you have to print the this classification report where you can see everything: precision, recall, F1 score, and support. So you no need to print each and every accuracy, precision, and all these things, the F1 score. Okay, so for each group it is showing. So our accuracy is 97%. It is good one, and for both the classes it is balanced, right? Precision, recall, and F1 score. So that's good. So our model is working fine. So we can check the confusion matrix also. Confusion matrix also takes the two argument. One is y true and y predictions. Okay. So you can see there is a this thing, but we can't understand this. So instead of that, we can visualize this by using creating a data frame. Okay. So you can see actual negative, predicted negative, actual negative. So this is nothing but a uh, true negative, and this is a true positive. Okay, so these values are maximum. Okay, this is true negative, false negative, and this is the false positive, this value, right? So we can show it on the graph also. By using a heat map, you can see in the nice picture of this. So this is the, and diagonal you can see there is a correct classified. These white numbers are misclassified actually, but yes, our model is predicting fine with 97% accuracy. Okay, now we will predict for the customized transaction. So I'm creating here the transaction data by using these numbers. Okay, these numbers up to the time, and here is the amount, and I'm creating this data frame here first. Okay, so you can see that data frame is available here for me. Okay, so I'll show you how this data frame look like, and then we'll predict this so that you can understand better here. So you can see the transaction data. I'll put it here. So I'll run this first, and here you can see this is a customized transaction I am doing. This is the class. Okay, now I am dropping the this, and I want to predict for these values, right? So what you have to do, if the new prediction is 0 1, then we can say it's a fraudulent transaction. Then if it is not, then it's a genuine transaction. Okay, so you run this, and you can see the time is 16. Okay, for time is 16, you can see there is a fraudulent transaction. Okay, now this is one. So I'm generating a 28 random transactions by using np.random. Here I'm creating a maximum time and minimum time and maximum time here, and random transactions I am creating and putting it into a list. Here the new transaction is I'm creating a data frame, and I am appending it into that new random transactions. Okay, so these things. So a random transaction, it will create a data frame here. So yes, so what we can do, so I'll show you how this look like here. So and again I will copy this and paste it here. so that you can easily understand what is going here. So then, yes, so we have to put here, we have to create the data frame here and copy, paste it here, and then run this here. So you can see this is the data frame which is created by using np.random and uniform. So these are the synthetic transactions we have created to check whether our model will predict it. Okay, for the test data we have created this one. So now I'm putting this in this particular, I'm running this for loop to check for every transaction, and it is giving us the result like genuine or it is a fraudulent transactions. Okay. So when you run this particular case, so you can see the transaction one is fraudulent, fraudulent, genuine, fraudulent like this for 28 transactions. Okay. Now it is giving a good result here, whether the transaction is a fraudulent or legitimate one. Now we'll check ROC AUC curve here for logistic regression. So we can check this y underscore. So here we are using the probabilities here, and logistic here method dot these probabilities you can see here, right? So you can check the false positive rate, then true positive rate and threshold here, and these are the values, and based on that I'm using this one to check or to draw the graph, that is ROC AUC graph. So now you can see that there is a nice graph you can see, that is the ROC AUC graph here, which is called as the receiver operating characteristic curve, or AUC is the area under the curve. Okay. So here the area under the curve is 99% is there. So means your model, our model is predicting correct and the accuracy is good. So by this you can create your own the machine learning model which can predict whether the transaction is fraudulent or legitimate by using a machine learning. So for this particular tutorial, that's all from my side. Thank you. Thanks for watching. Okay. Bye.